Hi everyone, my name is Attila Nagy and I'm a recent graduate at the Budapest University of Technology, and I'm presenting this work on automatic punctuation restoration with BERT models on behalf of my co-author Bence Bial as well, who's also a participant of this summer school. So let's talk a bit about why do we care about punctuations. So the place where we generally apply these algorithms is the output of ASR systems, which typically output unsegmented transcripts. So adding punctuations to these generally affects readability on one hand, and on the other hand, it can improve the performance of several downstream NLP tasks, such as like NMT, for example, or sentiment analysis or information extraction. So with this work, our contributions are twofold. We work on English and Hungarian. So for both languages, we re-implement a state-of-the-art model that is a BERT-based model. For English, we evaluate it on a benchmark dataset. And for Hungarian, we evaluate it on a gold standard dataset that we convert to an ASR-like format. And for Hungarian, there hasn't been a BERT-based model for punctuation restoration published before. So our architecture is a standard sequence labeling architecture with BERT. So once the tokens are passed through BERT, and we have the hidden representations, we pass all those through the very same classifier module that is shared in each timestamp. And that classifier module is showed here on the right. That is just a feed-forward network with two hidden layers with the parameters as shown on the image. So we also use multiple predictions on the output. So BERT takes an input sequence of 512 tokens, but what we can do is we take the text in overlaps, so that way we get multiple predictions for the same token, and we just simply take the average of the probabilities for the certain classes, and that way we derive the final classes. And that generally shows an improvement in performance in sequence labeling that it showed in our case as well. So quickly about the results. For English, we got really close to what was published in the state-of-the-art paper. So we had a 0.8 absolute difference with 10 epochs of training and 32 predictions per token, with the best model being an on-case variation of BERT base. And for Hungarian, our best model was the Hungarian BERT with an F score of 82.2. And we also were curious about the effect of having multiple predictions. So on the test set, we also evaluated the model with only a single prediction, and having multiple predictions increased F score by 5% in English and 2.4% in Hungarian. And as a closing remark, here are some examples from the predictions of our model, both for English and both for Hungarian. And with that, I thank you for your attention, and I look forward to seeing you all in the summer school.